Hi guys, so today we're going to look at how we use the proportions from the last videos to look at scale models and similar figures. A scale model or scale drawing is used to represent an object that is too large or too small to be drawn or built at actual size. The measurements of the real object are proportional to the measurements of the model or drawing. Think about things like a map. Think about the plans from an architect when they're building a building, a model car or plane that you would build. All of those are things that are scale models or drawings of real life objects. I can't draw the house on paper as big as it is in real life, or those plans would be humongous and I couldn't carry them around to the job site to build the house. Anytime we're working with the scale model or scale drawing, there is the actual scale. That scale is the ratio that's made by corresponding measurements between the model and the actual object. The model is going to be listed first, and we always want the model to have a unit of 1. So we want to know on the model 1 inch is equal to how much in real life. Or if it's a house, 1 foot on the model is how much in real life. Okay, that's what we're looking for. So our first two examples here, notice our instructions up top, finding the scale. So question 1 says a model car is 4 inches long. The actual car is 12 feet long. What is the scale of the model? And so there's a couple ways we can do this, but we can use the proportions that we did yesterday. And so what you want to think is, okay, the model is 4 inches. The actual car is 12 feet. We want the model to be 1. So how much is that in real life or in feet? So this means that 4 times x, 12 times 1. Nice thing is you're always going to be multiplying by 1. It makes it very short and sweet. Divide both sides by 4, and we get that x equals 3. What you want to do is write the scale. And so I'm actually going to type this. We want to actually say that our scale is that 1 inch is equal to 3 feet. We want to show that as a scale that would be listed, for example, on the box, right? This model car has a scale of 1 inch to 3 feet. Question 2 here, same idea. The pillars of the World War II memorial are 17 feet tall. A scale model of the memorial had pillars that are 5 inches tall. What is the scale of the model? So what you want to be careful here is if you're going to set up your proportion, it doesn't matter what you put on the top or bottom, but remember we want the model to go to 1. So if the memorial is 17 feet and the model is 5 inches, our other fraction, we want the model to become 1. We want to know what would that be in real life. And so if I slide this up, that means I'm taking 5 times x and 17 times 1, and I'm going to divide. And in this case, oops, my x is going to equal 3.4. And so once again, I'm going to show my answer. I'm going to say that the scale is 1 inch equal to 3.4 feet. Make sure you're taking whatever units are in the problem. So what are the units for the model? What are the units in real life? Both of these examples used inches and feet. That doesn't mean that all of them will use inches and feet. Okay. So this was finding the actual scale. In these problems, we're going to find an actual measurement. In the problem, they're going to provide you with the scale. So for example, in number 3, the blueprint of a skateboard ramp shows that its length is 11.4 inches. if the scale on the blueprint is 1 inch equals 6 feet, what is the length of the actual skateboard ramp? So in these problems, they're going to give you the scale, just like we just found. That scale is one of your fractions. So find your scale, set up your fraction. 1 inch equals 6 feet. In the second fraction, they have to give you a measurement, and they're asking you to find the other one. So they gave me that on the blueprint, it's 11.4 inches. So 1 inch, 11.4 inches. We got to make sure they're on the same part of the fraction. We're looking for the actual length then in feet. The nice thing here is 1 times x is just x. 6 times 11.4 is going to be 68.4. And then make sure that we label it with a unit, in this case, feet. If you put the 1 in front of your x, you could divide both sides by 1, but because it's a positive 1, doesn't matter, we're going to get the same answer. So if you want to try number 4, go ahead and hit pause. I'm going to go through number 4 so that you can see it, and if you did it, you can check your answer. A map has a scale of 1 inch equals 20 miles. 2 cities are 3.25 inches apart on the map. What is the actual distance between the 2 cities? So again, I'm going to take the scale, 1 inch, 20 miles, equals my new fraction, 3.25 inches. So this is the map measurement, 3.25 inches. And we want to know, what is that in real life? What is that in miles? So I'm just going to slide this up. If I cross multiply 1 times x, again, okay, that's nice and easy. There's my x. And then 20 times 3.25 is going to be 65 miles. And we want to make sure that we label our answer, because these are word problems. So let me slide this a little bit. So here are 2 examples where you're finding a measurement. In the word problem, they have to give you that scale, and that scale is going to help you set up your first fraction. Just make the second fraction match in terms of what unit is on the top and what unit is on the bottom.